Hey guys, I got one more video for you about chapter 2.2, just because even and odd functions, they throw people off some of the time. So 2.2 has a lot more than this, but even and odd functions is the most easily forgotten topic. So I just want to talk about it for a second. The definition of an even function is a function that's symmetric about the y-axis. So what I mean is, like, if you took, say, a parabola, then it should be symmetric about the y-axis. Every point on this side has a corresponding side on this axis. This is the graph of y equals x squared. Odd functions are symmetric about the origin then. So a good example was taking like a line, or y equals x cubed. Let me try to get this axis a little straighter. If you took y equals x cubed, it does this sort of thing. Where it's symmetric about the origin, every point that gets mirrored through the origin shows up down here. So there are corresponding points on opposite sides of the origin. Algebraically, we can tell that a function is even without having to look at the graph. All we have to do is evaluate the function at negative x and see if that equals our original function. So if f of negative x is equal to f of x, then we have an even function. Otherwise, if f of negative x is negative f of x, then we have an odd function. A function doesn't have to be even or odd. It could be neither. So this doesn't have to happen in either case. But even functions are symmetric about the y-axis. The idea is if I take this x value and I plug in the negative of that x value, then I should get the same output. I should get the same y value. So that's for even functions. For odd functions, the idea is not only when I plug in the x value or if I evaluate at negative x, should I get the same value, but I should get the negative of the value that I got when I plugged in just x. So the idea is f of x should equal negative f of x in order to be odd. If f of x and f of negative x are the same, then that is an even function. So let me just draw up a few examples. Like let's take y equals x squared, for example, or f of x equals x squared. I just said this was an even function. The idea is that if I look at f of negative x, that's equal to negative x squared. I'm just replacing the x with negative x instead. But negative x times negative x is still x squared. These two are the same. They're equal. So then that gives me that that this is an even function. I just showed you by the graph why it was an even function. But now you see that it is still even. Or even algebraically. But say instead of just f of x equals x squared, maybe I take f of x equals x squared plus x. You can look at that graph and try to determine whether it's even, odd, or neither. But the idea is that if I look at f of negative x squared plus negative x becomes, well, negative x squared is still positive x squared, but then plus the negative x becomes minus x. What you see is these two are not equal. F of negative x does not equal f of x, so that means that this is not an even function. That's all I can say for now, because that's the test for an even function. the test for an odd function is look at f of negative x and see if that's equal to negative f of positive x. Well, negative f of positive x just means make the whole function negative. And then in this case, you get negative x squared minus x. So these two are not exactly the same. That means that it's not the same, not an odd function. Remember, to be an odd function, f of negative x has to equal negative f of x. These two are not equal either. So this is not an odd function either. So it's neither even nor odd. Let me show you an example of an odd function. If I had f of x equals x cubed, then f of negative x, that's what you start with in either case. You have to look at f of negative x is negative x cubed, but a negative times a negative times a negative is still a negative x cubed. These two are obviously not the same. That's why I don't have an even function. F of negative x does not equal f of x. But negative f of x is the negative of x cubed. That's slightly different at first, at least at first glance, but negative x cubed is just negative x cubed. These are the same. These two are the same. So this is an odd function. And check this out. Even if I have something like f of x equals x cubed plus x, f of negative x becomes negative x cubed plus negative x, which is negative x cubed minus x. And so it's not an even function. But then to test for an odd function, I look at negative f of x and compare it with f of negative x. That's negative x cubed plus x. Don't forget that this negative belongs to both of these terms, so this becomes negative x cubed minus x. So now this is also an odd function as well. X squared, when I added the x, wasn't even or odd, but this one was. I can show you an example where I make x cubed not even or odd. I could take something like f of x equal to x cubed plus 5, or plus any number. F of negative x becomes negative x cubed plus 5, which is negative x cubed plus 5. These two aren't the same. They are not even. So if I look at negative f of x, then that's negative x cubed plus 5, which is negative x cubed minus 5. And so these two don't match either. This is not odd. These two don't match, so it's not even. F of x does not equal f of negative x. That's what we said had to happen algebraically in order for it to be an even function. But then f of negative x doesn't equal negative f of x either. That's what we said had to happen in order for this to be an odd function. So it's not even or not odd. So I posted an example on Math Excel. I'll show you the different types on Wednesday in class. But for now, I just want you to understand that the definitions of even and odd are the symmetry and why the symmetry happens. If f of negative x equals f of x, then I have an even function. That means it's symmetric about the y-axis. If f of negative x equals negative f of x, then that means that the graph is symmetric about the origin. That means that it is an odd function. Okay, so a function doesn't have to be even, odd, or neither. I'm sorry, a function doesn't have to be even or odd. It could be neither. If I pull up, say, the one very similar to what I gave you, well, maybe I won't do the one like I gave you. I'll go back and do, I don't know, a different one. There just might be more terms. So maybe I have something like f of x equal to, say, x to the 10th plus x to the 7th plus 3 or something. And I want to determine whether this is even, odd, or neither. Then I just look at f of negative x. This is the test for even only because I'm just looking at f of x and f of negative x and comparing them. Negative x to the 10th, I'm raising a negative number basically to an even power. So that's going to be positive. Negative x to the 7th is going to be negative, and 3 just stays the same. So this stays x to the 10th minus x to the 7th plus 3. And when you look at negative f of x, that becomes negative x to the 10th plus, negative x to the 10th plus x to the 7th plus 3, all in parentheses. But that negative belongs to the x to the 10th minus x to the 7th plus 3. Minus 3. The point is that I did the first one. They didn't work. They didn't match, so otherwise I would have stopped there. This is not an even function. So then I said, okay, well, is it odd? When I looked at negative f of x, that doesn't work either. So this is neither even nor odd. All right, so try the one on Math Excel. There's actually 2 problems for today, so make sure you get them both done for 2 points extra credit.